Here's everything I know about space in 1 minute. Let's go. Okay, so let's start off with the solar system. So the planets in order are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, no, Uranus, Neptune, and then Pluto, which was demoted to a dwarf planet in 2008. The other dwarf planets are Ceres and Eris. I can't really remember the other ones. And okay, so the solar system was formed 5 billion years ago when the sun was born. The sun's a yellow dwarf G-type main sequence star that will die in like 5 billion years. So it'll become a red giant, swell up, and engulf a lot of the planets. And then it'll become a planetary nebula, and it's like the remaining core will become a white dwarf. And this is unlike high mass stars, like really massive stars. They explode into a supernova explosion, and they either become a neutron star or a black hole, a stellar mass black hole specifically. And the other type of black hole is a supermassive black hole, which is located in the center of every galaxy. And supermassive black hole located in the center of every galaxy. And black holes are basically these objects in space which bend the curvature of space so much, they bend space and time, that the gravity is just extremely strong, and no object, not light, not anything, can escape the black hole. And time slows down a bunch around a black hole. So if you were to be like in a rocket ship far away from the black hole, you'd like and if you waited for like 10 years, the person like that's right next to the black hole would still be young, while the person on the rocket ship would be older. So, and this is like kind of like the idea of the twin paradox, if I'm saying it right. It's just hard saying it in a time crunch. Anyways, also the other type of theoretical black holes are primordial black holes, which were hypothesized to form in the early universe, like the first few milliseconds in the universe, like that early, because the conditions in the universe were just right at that time for primordial black holes to really tiny black holes, like atomic size, to form. But there were also like decently sized primordial black holes, like 10 solar masses, like actually decently sized in the early universe, that are hypothesized to have formed supermassive black holes now, because the formation mechanism for supermassive black holes is still unknown, and primordial black hole mergers is one of the theories for that. The other merger is primordial gas collapse, where there was a big gas cloud. There were big gas clouds in the early universe when the density was really high, and this high density led to the gas cloud directly collapsing into a black hole instead of collapsing into a star first, then like becoming a protostar, and then a normal star going through nuclear fusion. Instead of that stuff, it just directly collapses into a black hole. Anyways, let's get back to the universe now. So the universe was formed 13.8 billion years ago from the Big Bang, and during the Big Bang, so cosmic inflation happened in like the first 10 to the 30th seconds or something. I forget the number, but yeah, 10 to the 30th seconds, the universe expands like more than 20 orders of magnitude larger. And then yeah, its expansion starts. The expansion never gets like that quick, that absurd. That was just for the first 10 to 30th seconds of the universe. And okay, let's talk about dark matter. So dark matter is actually no, dark energy first. So dark energy is what's driving the universe's expansion and accelerating its expansion. Dark matter accounts for about 70% of the universe's energy or matter or something, and it's hard in a time crunch. And then dark matter is basically what's hypothesized to be or not hypothesized, it's what's between galaxies. It's what holds galaxy structures together, because already proven by models and stuff. If there was no dark matter, galaxies would not be able to be held together. They just fly apart, and we'd have no galaxies. And speaking of having no galaxies, in the early universe, so when the Big Bang happened, you can see it in the cosmic microwave background radiation. There were very subtle density fluctuations. Like some places had just a tiny bit more dense. They were just a tiny bit more dense than other places, but these tiny dense pockets eventually grew into really dense pockets, these are what led to galaxy structures. Like if there weren't these the density fluctuations in the early universe, galaxies could not have formed. We wouldn't have been here. And yeah, that's we found that out when we saw the cosmic microwave background radiation, which was discovered when I don't want to get into that now. What else? What else is there? Did I forget anything? I think that's about it. I'm gonna end it there. See you. Subscribe if you like space.